to our mini webinar today. We're focusing on heat pump dryers, update on all the brands and options that are available. There's a lot going on in this space. We're really excited to introduce our guest speaker today, Steve Sheinkopf from Yale Appliances. We'll introduce him in a minute. My name is Brian Stewart from Electrify Now, and I'm joined as always with my colleague, Joe Wachunas, also from Electrify Now and also from NBI. He also works there. So thank you for tuning in. We hope we'll be able to give you a lot of good information today on kind of a device that a lot of people are not very familiar with. So in case you haven't heard of us before, we're Electrify Now. We really try to educate people on how we can all be part of this amazing energy transition that's happening. We try to keep it really simple for people so they can participate, and we try to break it down into these 4 steps by cleaning up your electric supply through green energy that you can get in your home pretty easily. We can tell you how to do that on our website and electrify your home. So today, obviously, that's one of these heat pump dryers are one of the devices that are going to help us to electrify our homes and get ourselves off of fossil fuels. And then, of course, transportation is a big deal. And then we also remind people that we need to bring everyone along on this journey with us so that everyone can enjoy the benefits of electrification and reduce carbon emissions in their home, but also have safer, healthier and more comfortable places to live. So lots of information on our website. Speaking of electrifying everyone, we really appreciate you, your donations that you've provided for Seeds for the Soul, one of our partner organizations that puts solar panels and also heat pumps into low-income families. And they do this in an amazing way where they can do it with no upfront cost to the families, and they repay these loans through the energy savings that they get through these more efficient devices. So thank you for your donations, and we really like supporting this organization. Joe, you want to tell us about the...
Yeah, we're really excited about our next upcoming webinar. We haven't published it yet on Eventbrite, but we'll let everybody know when we do. Just want to give you a sneak peek. We're going to be talking about micro heat pumps. These are going to include window, portable, and these, as you can see in the picture, saddleback heat pumps that stay on either side of the window. Lots of exciting things to update there. Christopher Diamond from the Northwest Energy Efficiency Alliance will be our panelist. And of course, you can always go see all of our great previous webinars at just Google Electrify Now, YouTube. So many great educational resources there at your fingertips.
Thanks. And so there's a couple of things we like to start out with, just a few things we're keeping our eye on. And if you get our newsletter, you probably would have seen this, but it's 1 year now since the IRA was ratified, and there's a lot been going on. This is just one snapshot of it, which is what's happening in terms of manufacturing, clean energy manufacturing in this country. In the last 12 months, 83 new manufacturing facilities have been either started or announced, and $270 billion of investments in these clean energy manufacturing locations. You can see there on the map all over the country. That's 8 times what's happened in the past, or in 1 year, we've done as much as we did in 8 years beforehand which shows you the impact of this IRA bill. Lots of new jobs, almost 30,000 new jobs. And these projects are in solar panel manufacturing, wind turbines, battery storage, and other EV supply chain manufacturing facilities. This doesn't include, by the way, things like new energy generation facilities. That's not in this number, which would make the number of jobs even bigger. But it's a good snapshot of how important that bill has been to get us on the right trajectory from manufacturing side. The other thing we're keeping our eye on here is here in Oregon, and these little battles happen all over the country, but here in Oregon, we just kind of had a pretty important victory in the Public Utility Commission, which regulates the gas utilities here. Avista, one of our local utilities, was really trying to raise rates dramatically, trying to get customers to pay for lobbying and legal fees for their fighting climate legislation. And both of those things didn't happen. The PUC refused their entreaties to do that. And also, really significantly, they agreed to phase out their subsidies for new gas hookups, which is really important news because many of you might not know this, but the gas utilities all over the country make it really cheap for people to hook up to gas supply, which makes it easier for new homes to get on gas. And this is making it more realistic in terms of what the real costs are which hopefully will slow down the proliferation of new gas infrastructure. So another little victory here. One more, we need lots of these all over the place, but something that we're keeping our eye on.
And we'll send links to those articles in our follow-up email.
Yeah. All right, Joe. So why are we talking about heat pump dryers?
Well, this appliance is near and dear to my heart. Really an exciting emerging technology, at least for the United States. New models, new options. So we wanted to chat, and we'll introduce our panelists in a second, with one of the people leading the charge on carrying these new heat pump dryers. So the heat pump dryer, we call it the new kid on the block. It's joining its cousins over there, the space heating and cooling air source heat pump on the left, and then the heat pump water heater in the middle. The heat pump dryer, it has been well known in Europe. Our research showed that the number that we could find was 2014, and 42% of dryers in Europe were already heat pumps in 2014.
That was almost 10 years ago. That was almost 10 years ago. So it must be much higher now.
We're already at half the market in Europe. So they're relatively new to the US, and yeah, they're joining the other technologies. Manufacturers are getting on board. We're seeing the number of heat pump dryers increase from 2018. There were 16 models certified by Energy Star to 42 models today, and that's 11 in the last year alone. So really exciting that there's more options. With larger sizes, we'll see some of the complaints are that they're more compact. To date, the dryers have been more compact, and we're seeing a couple of them come in under $1,000 as well. And of course, you might be like, well, you could just hang dry your laundry. Most of the world does that anyways. And we're totally on board with that. If you haven't seen, we've been promoting Hang Dry Week all week. This is a chance to try hang drying laundry, seeing how amazingly efficient it is to just put clothes on a line. It works great in the summer. And we feel like these technologies are really comparable. Summer hang drying, winter heat pump dryers. It's a perfect way to reduce your energy use and emissions. So just go to hangdry.org and participate in Hang Dry Week. Big plug for that.
Well, great. Let's introduce our panelists today. We're really excited to have Steve Sheinkopf with us. He's the CEO of Yale Appliance. We've had him on before because he really knows a lot about appliances. He runs one of the nation's oldest, and we consider most sophisticated appliance dealers. And we say most sophisticated because if you go to their website, you'll see the amazing amount of information they have to help you as a potential customer buy the right product. And he's developed a wealth of experience with his organization around some of these things that are relatively new to us, like heat pump dryers, induction cooktops, and that sort of thing. But basically any appliance, you can get good information from their website, and they do a great job of consumer service there and have experience with basically all the major appliances. Of course, they don't carry everything, but they're aware of pretty much everything that's out there, which is why he's a great resource to talk about something like heat pump dryers, which is a little bit unfamiliar to most people.
Yeah, we got two. All right. This is the interactive portion of our webinar. Just if you guys could guess what is the most important period of time for heat pumps, it would be the 1850s. Right? The decade before the Civil War. Did it cause the Civil War? 1970s, the disco era. 1990s would be the grunge era, and the era not yet to be named, 2020 to 2023. Take a guess. All right. Well, if you'd guessed anything, you'd be right, because heat pumps were invented in the 1850s, 1856 in Austria. In 1970s, they became popular as a response to OPEC. OPEC jacked up the cost of gas, so people looked at heat pumps as a way to mitigate costs. 1990s, Electrolux put that heat pump in the first dryer. In 2020 to 2023, you see an explosion of innovation, as Joe was talking about, a lot more models. Miele is now all 110 heat pump. We have the wash tower that we're going to talk about, the G combination washer dryer heat pump we're going to talk about later in the presentation. Next slide, please. Okay. I always think of my Oldsmobile Cutlass. I used to drive an Oldsmobile Cutlass in the 1990s. My dad's old Oldsmobile Cutlass. Seriously, you have to laugh, Brian. I was proud of it. Didn't even have a cool spoiler. So I really want you to think of these new technologies that are new to you. Click, please. As it was invented at the same time I was driving a Cutlass Supreme. So let's get to next slide, please. All right. Now, if you go online about how heat pumps work, you're going to get more confused. So I just want you to think about it in two ways. You've got a condenser that generates the heat in a closed loop with an evaporator takes the water. It's just a closed loop, right? So over time, that air becomes warmer and warmer and warmer until it becomes hot. So the condenser doesn't do so much. Now, if you compare and contrast that with the way an electric dryer works, where it draws in air, it uses old-fashioned elements to heat, and then it expels it through the rear. So it's always bringing in cooler air. That's why heat pumps are more efficient. But what does that mean for you? Should you change from your regular dryer that works fine to a heat pump? Next slide, please. So this is the other thing is you look at the comparisons online, everyone says it's 12 cents. It's 12 cents a kilowatt hour. It hasn't been 12 cents a kilowatt hour in a long time. Now, I did in Massachusetts, we crested 34.1 cents per kilowatt an hour. I did one in California because I know a lot of Californians on. You're 19.9 cents per kilowatt hour before distribution. My actual all-in is 28.1 cents per kilowatt hour. That's what it costs to run for kilowatt hour. Now, people don't understand how much energy dryers use. Next click, please. Right? Average kilowatt per hour, according to Whirlpool, is somewhere between 1.8 to 5 per kilowatt hour, right? Now, if you've got an older dryer, I guarantee you're on the 4 to 5. But just to make the numbers round and just add raw averages, we put it at 3.4. Okay, so if I took my utility bill at 21 cents a kilowatt hour times 3.4, that's 0.96 cents. Cost me almost $1 to run a dryer, right? So over here, next slide, please. Right, one load a day is $350. Heat pumps, because they recycle reused air, will save 50 to 60%. So minimum, that's for me and my daughter, it's $175. But if you're looking at a family of 5 that's doing multiple dryers, multiple loads and an old dryer, you could be talking $300 to $400 a year easily. Dryers, I think after HVAC, use the most power in your house. Next slide, please. So let's go on the pros. We just talked about low energy costs. They're also dry at a lower temperature, so they generally are closed. And we're going to talk about why they probably don't even need to be even that hot. And they're ventless. So you don't have to run a vent to your house. You don't have to clean your vent, which you should be doing every couple of years because the lint buildup and it's a possible fire hazard. And these can operate, a lot of them, when we talk about, the G Ultra Fast and Miele, operate on 110 volt, right? 110 volt. I know I'm not rolling in mud for the person, but I work out every day. So that means every room that's got a drain and regular electricity can now be a laundry room. So you're not tethered to the outside, right? So any room now can be a laundry room with a drain and just 110 power. Next slide, please. Now we talk about the cons. Everyone says, well, heat pumps take longer. That's not really true. Now we measured the ultra fast. I imagine you're sending this presentation. You guys can look at that later. We did the G washer and dryer, what it takes for a normal washer and dryer that everyone has. For whites, it's 127. For whites, it's 149. For colors, it's 127. For mixed colors, it's if you look at the wash tower, which is the heat pump version, it's 134, 154. It's not a lot of time. Problem with the wash tower, it's all sensor driven. So if you use a sensor dry to get comforters and bedding completely dry, it'll take multiple hours. But if you put it on a 2.5 hour time dry setting, it'll work just the same. So it's not a huge amount of difference. You're looking at 7 to 20 minutes difference in time. That's not a lot. Next slide, please. Okay. You take a look at reliability. We did 34,000 service calls last year. Bosch is 3 point. The average electric dryer is fixed 3.5% of the time within the first year. So Bosch is always the most reliable. Well, I looked at Miele, it's 11.9%. Like there's no way. We delved into it. The error code that we're going out to fix is actually to replace to take the lint out of the dryer. There's a little filter in the front that you have to fix, that you have to change. You have to take some of the lint out. If you don't take the lint out, it's an error code. So we're naturally going out. So the lesson I learned is just tell people to just take the lint out. So really, if you take that out, Miele is around 4 to 5%. So they're pretty reliable. The problem with reliability, now you're not talking about changing elements. Now we're talking about evaporators, heat exchangers, and condensers. So it's a much more sophisticated repair. Next
Steve,
slide.
that's a really great point that maybe we should just harp on a second. the heat pump dryer, could you tell folks, they have a slightly different filter configuration, it's 2 versus 1. And was that the problem that folks were running into? They weren't changing that second filter?
Yeah, there's a filter in front. I'd like to talk. So I said I was told I had 10 minutes. There's a filter in the dryer, and then there's a separate filter. If you look at the go to the next slide. Right, you see that on the right of these dryers? That's called a plinth filter. You've got to actually take the lint out of that as well. If you don't, you'll get an error code.
Gotcha. So there's one that, just like most dryers have, that every
Yep.
time you do it, you take it out, but that one you've got to do like every once in a while. Is that what you're saying?
Yeah, every once in a while.
Yep.
I mean, it depends on the instructions, really. Okay, I'll talk slower. Now, there's a lot of heat pump dryers out there. We don't carry Samsung. Electrolux was the first, as you know. We carry Beko, which is actually, they were the first to export a heat pump dryer. Number one, through the Blomberg name. They're actually a cool little company too. They're from Turkey. What they do on their outer drums is they're made out of recycled plastic from the ocean. So every year they're recycling millions of pounds of plastic. When we look at Bosch, everyone's familiar with Bosch. Tends to be the most reliable compact set of washer and dryer. And then you look at Miele. Miele is the most technologically savvy. We have washer webinars, but they've got the 32 load dispensers. They even have fragrance dispensers in their dryer, and they're all 110 volt now. So let's go to the next slide, please. Okay, now we talked about why heat pumps dry at a lower temperature and why that may not be as important. The average top load is going to spin at, say, 600 to 800 RPM. These front loaders are spinning out at 1400. Miele tops out at 1600 RPM. That means all that water is really, most of that water is extracted out of the wash. I used to have a Miele. If you look at if you take the clothes out, they're somewhat dry. They're not moist at all. So really the dryer is not doing a lot of the heavy work it would, say, on an old-fashioned top load that fills the 40 gallons, or say even on the Speed Queen or the Maytag commercials, the 70 gallons under soak cycle. When they come out, they're soaking wet. These are mostly dry coming out of the washer because of the spin speeds. So it's something to think about. So the dryers aren't doing the heavy lifting they once did. These are the compacts. These are the ones that mostly are imported from Europe and other places. Next slide, please.
And Steve, real quick follow-up question on that. Would you kind of go as far as to say rule of thumb is don't get a top load washer with the heat pump dryer, or just expect longer drying cycles? Well,
you can expect longer drying cycles, but typically you're not going to do that anyway, because your top load washer is going to be like a full size. And all these compacts are around 4.0 cubic foot in terms of capacity. So I wouldn't do that. There are I'm going to show you a couple slides at the end. You might want to do that, but you're not looking at, Whirlpool has a full size compact, has a full size heat pump, but they still need at one time they needed a repairman to take the lint out of it. So I would never sell that to a consumer knowing you've got to have a repairman take the lint out of it. Now, I don't know if that's changed, right? Again, these are all around 4 cubic feet, all the compact ones. So I wouldn't do a top loader with a heat pump dryer.
So Steve, just 4 cubic feet, what's a typical US dryer, the non-compact, what does that mean? Is that more like 6 cubic feet or something? Or what's the difference in size?
Well, that's in the next 2 slides, but it's not okay. The Whirlpool may have changed since we carried it, but the new ones now have the wash tower is 7.2 cubic foot. The G Ultra Fast is 4.8 cubic foot washer and dryer, but those are brand new. Larger heat pumps really have only become more in vogue over the last 2020 through 2023. You didn't see them before that. They were mostly a European, the Europeans kind of live differently in smaller spaces. So that's why you see the smaller, those washers and dryers are 34 by 24 by 24. That's not an accident, because you can put them in kitchens, you can put them in small closets, they stack nicely, and they can go into kitchen cabinets. So that's why these are what they are. And they're all from Europe, and they're all designed for smaller spaces. Okay, so here's just a interesting question. Bosch is a 220, Miele is 110. Which one's faster? If you're going to say Bosch, it's about the same. It takes the same to dry between a Bosch and a Miele. And the reason is we tried it a couple of different times. Miele's got mineral sensors in it. So it adjusts the sensors by the mineral content in the water. I just thought that was interesting. Has nothing to do with the topic, just interesting. Next slide. Now you're seeing kind of the mainlining of where heat pumps are going to be. We're going to talk about the future here. This is the wash tower. The only thing my friends have ever asked me about in the 37 years I've been at Yale has been the wash tower. It was introduced during the pandemic, so there really wasn't much else going on. The wash tower did something really unique insofar as instead of buying two pieces where you have a control at the top, now they put the controls in the middle. And they also added a lot of technology to it where you just hit a button for your favorite cycle and it just goes automatically. Or you have the sensor driven where it's got sensors in the washer and dryer to actually change the washing and drying based on the fabric and softness of the clothes. This year they added the heat pump dry. First one at 7.2 cubic feet. Right, that's the first one that's been popular. I mean, there's other ones that are fringe. Next slide. And then we're talking about the GE Ultrafast, which is washer and dryer in combination. So it's a washer and dryer, so you never have to transfer your load, which is a problem mostly. Combination washer and dryers have never worked. And the reason is because they've never effectively removed lint. And what happens is that lint stays in the machine. It's an almost certain service call. Now, I get a lot of pushback on the internet for that, but I happen to have a couple of talks with the guy who designed the Ultrafast, and he admits, he goes, combinations can't get removed lint, which is why, next slide, please, next click. They put a huge lint filter, double-sided, right next to the heatsink of the washer and dryer. So if we take a look at how we're going to wash and dry in the future, it's going to be adaptations of this, because you got to believe they're going to refine this technology here. It may be a compact for people who live in apartments, or go backwards to the wash tower. And the wash tower is it's a great piece of equipment, because the one thing a combination can't do is once you hit it, it's washing and drying. So it's going to take 2 to 3 hours to do that cycle. Whereas on a washer, it's 28 to 58 minutes. You can reload that washer and then put it in the dryer, which is something you can never do in a combination. So I think we pretty much covered everything from 1850 to Oldsmobile to the future of how we dry. And this is going to be it. It is far more efficient than a regular dryer, only because regular dryers have been around for 100 years. It will save you money. It will be gentler on your clothes, and you don't have to have a laundry room anymore. Any room can be a laundry. And with that, I'll say thank you. We have a lot of this stuff at our blog, and I have several conversations with the guy who designed YouTube on who designed the Ultrafast on YouTube. All this stuff's free. We're happy to, and I'm happy to answer any questions you have.
Yeah, a huge +1 to Yale Appliances and their blog. That's where I did a lot of research on the new GE dryer from Steve's conversation with them. So yeah, we'll send out a link to that website as well.
The gentle on your clothes thing is no small thing either. It's crazy. I mean, first, drying on high heat is just like one of the worst things you can do for your clothes. And with all that lint that ends up in the filter, that's just your clothes falling apart over time. I mean, that's so the less of that, the better. Lower temperature is definitely good. It's one of the reasons why hang drying is such a nice thing to do. But these machines that operate at lower temperatures, huge advantage in terms of keeping your clothes good for longer. So
if you think about how the majority of America washes their clothes with a agitator that's been around forever and just a regular dryer, and if we could replace that, I mean, I wonder what kind of load you get off the grid just from doing that, just from washers and dryers. And if you have a family, it may be an extreme case because I do a load every day. You're going to save a lot of money. I mean, the problem with green and Electrify Now, or not to single anybody out, is, yeah, let's go green, but no one ever says that. No, if you talk about an ROI, a return on your investment, saying, yeah, you're going to spend a little bit more now and you're going to save at least $150 a year for your family and possibly a lot more. That's a far more compelling argument.
Yeah. Yeah. The 110 thing is another thing I want to just kind of chime in on, because, particularly if anyone out there, if any of you have a gas dryer now and you're considering going to electric, you're going to have 110 already there, but you might not have 240. So it's going to make the conversion from gas to electric a lot easier. Wouldn't you say, Steve?
Oh yeah. I mean, absolutely. No question about it. There's so many soft costs that we don't talk about. I mean, you hire an electrician, you get them in a month and you're happy. And it's not a simple thing of just rewiring, of putting a plug in and immediately calling it 240. You got to wire back to the box. And for a lot of people that are in condos and everything, you may not have the amperage to do that necessarily. Most of the time you will, but getting, changing the box, rewiring to the circuit, it's not like, it's not a simple thing to do.
Hey, Steve, John is wondering about, okay, so he's got a laundry room on this home second story, and he's wondering about that drainage. So I'm wondering if you could talk about that compartment that heat pump dryers are, the different options for draining the water that the heat pump dryer collects.
Yeah, I mean, if you're going to buy a heat pump dryer or even a condenser dryer, which is just heating elements that's ventless, Ventless Technology, this has been around 20 years, right? What you want to do is run the water line from the dryer to the washer. So every time the washer waste goes, it'll go down with it, the water from the dryer will go down with the same drainage as the washer. That's what you want to do. We've been doing that for years. That should be delivered that way. Now, let's just say that isn't done. Well, there's a compartment in the top, right, where the water will collect if you don't do that. And then every load, you've got to just take this unwieldy tray of water and drain it at the closest sink.
Yeah, for sure. I run my heat pump dryer into where the washer drains out exactly. But yeah, there's this other compartment. But you're right. It's a little bit unwieldy if you want to do that every time. Yeah. Brian, you got a question on the tip of your tongue?
Well, I wanted to address the thing about noise, because I had heard someone say that they thought heat pump dryers were really noisy. Have you heard that, Steve?
I haven't heard that. I think really the problem that, well, quite frankly, the problem you're going to have is if you're putting this, like, say you're in a condo, I think there's going to be more of an issue with the washer spinning out at 1600 RPM and making sure that, the laundry room's constructed properly for that than you ever would on a heat pump dryer. I haven't heard that heat pumps are any noisier than anything else. Again, the fact that the zipper is going to hit the side and everything else, I don't see, that hasn't been a complaint that I fielded, quite honestly.
Okay. We did get this question, maybe this is a little myth busting, Steve, about, it keeps coming up about the heat pump dryer potentially making a house or a room colder. Do you want to field that concern?
I don't see that. Again, logically, I don't have a heat pump dryer yet. That said, you're talking about using the internal air and basically recycling it. The problem that we've had with condenser dryers is what happens is, because they're ventless, is they project the heat out. If anything else, it would make the room hotter, not colder. But again, we sold 50 of the ultra fast, a lot of the wash towers, and we haven't taken them back because of the heat, or it hasn't been a common complaint of that yet.
Yeah, I agree with you. I don't see how it would reduce the temperature in the room, because it's a closed loop. Like you say, you're not venting the air outside. There's all that energy is staying in the room. It's just, we're just moving it a little bit from one place to another, but it all stays inside the room. So yeah, I don't see that it would change the temperature of the room.
The old condenser models do. They definitely make a room hotter. No question about it.
Yep.
Heat pumps, I don't think so.
Maybe talk about the difference between, somebody was asking about a condenser dryer and a heat pump dryer. Can you spell the differences there, Steve?
Condenser is just basically let me make it easy. It's a ventless electric dryer. So it uses the same electric elements. So what happens is, instead of projecting the heat backwards, it projects the heat forwards.
Right. So it doesn't vent them
Really,
out.
I mean, it has got condensers in it that with the water and everything else, where the water goes in a different place, but other than that, it's really the same elements. It's the same principle, only you're reversing the air going out, coming back in.
And not near,
Less the moisture.
and it's not as efficient as the heat pump dryer. The heat pump.
No, no question about it.
Got it. Great. Okay, we covered that
There's
one.
this question about average increase in drying time versus a gas dryer. I mean, we were talking about electric. I think the comparison that you had was to electric dryers. I mean, would you see a big difference between a gas dryer and a heat pump dryer in terms of drying time?
I'll be honest, I hadn't really even thought of it because we sell so many more electric than gas. You know, gas has got the glow bar. I don't know. I never really thought of the difference between a gas and electric dryer. Usually when a person has one or the other. I don't think it's any faster than electric, or certainly not. I mean, that's not a reason why people have bought it in the past. I mean, I could do some research and certainly get back to you guys on that.
Okay.
I think there's a general rule of thumb. I've had heat pump dryer for about a year now. In a webinar last year, I showed my heat pump dryer on camera when we first got it. It's usually, I found that it's usually a little bit longer. The cycle time starts at 75 minutes. You know, it might go up to 90 minutes depending on how full the load is. So it's usually a little bit longer. And anecdotally, people I've talked to have said that the heat pump dryer is a little bit longer. So something to expect.
Well, you know, what's really funny is they have a projected time on all of these, but it's always less than the projected time, except for bedding and comforters. Bedding and comforters, they don't get right. But in terms of everything else, it's always less than they project. At least when we tested the ultra fast and the wash tower, where we have a projected time of what they say and how long it took. It's always like a few minutes less than what they project. And I guess that's just a function of how dirty, or I mean, how wet the clothes may be. But again, you know, you're looking at the wash tower and the G is 1300, 1300 RPM. So it's still a higher spin speed too.
Right. Somebody was asking about repairability, Steve. You mentioned that a little bit in the slides. You know, you said that most of the repair was just people weren't aware of that second Plinth filter. But in general, because it's a more complicated machine, would you expect more complicated repairs?
Yes. Definitely. I think it's the only really kind of like, and again, we have to project this forward 5 years to say what is this? Because the one thing about electric dryers is pretty simple. It's just basically a toaster oven or a hair dryer in a steel drum, right? So all that heat gets projected through the steel. Heat pumps, you don't know, because you've got, you know, the heat exchanger, you've got condenser, and you've got evaporator. So
more there.
There's
Yeah.
a question about rebates and incentives. As far as I know, the IRA does not give a tax credit for heat pump dryers, but I believe the HERO program has a rebate potentially involved in it for heat pump dryers. Is that correct? But that most states that hasn't ruled out yet, so those aren't available. But is that how you guys understand this?
we're having a hard time figuring out the home rebates. I think we've sort of more or less given up on that, because I think there's a home inspection component to that, I believe, but it's not quite easy, at least in this area. There aren't any really easy incentives to get when you're talking about, you know, things that should be incentivized or induction and heat pump. We haven't really seen that flow through yet.
In California, there's really good incentives for heat pump dryers that they're vary from location and utility to utility. But you know, if you check out switches on, for example, you can get is a really good. If you Google switches on, that's a great source for understanding the California rebates. You know, they're only available in state, but they're really good. So I would check that out if you're tuning in from California.
Yeah, and Energy Star also has a rebate finder. If you just Google Energy Star rebate finder, there aren't. Nationally, I haven't seen a ton of heat pump dryer rebates available yet. But Steve, you know, one of the big technologies in this is this GE combo washer dryer. Just, you know, it's just hit the market. You're just selling the first ones. What would you want to see before, you've said before combo washer and dryers have a lot of challenges, but what would you want to see from this GE dryer after a couple of years? What kind of feedback would you want to see before you were able to give 2 thumbs
First
up?
of all, I think it's a really inspired, again, we're talking about the appliance business, so it's pretty easy. It's a pretty low bar, but in terms of they really thought it through. That guy, Ken, his name's Ken Rudolph. His team did a really good job, because really, there's been so many combos, and I always say these things don't work. And I always get someone who's always said they love theirs, and it's always like a single guy who travels consistently and does 1 load a week. Well, yeah, sure, use it. It won't be a lint problem, but they've really thought it through from the whole lint capturing. It's a full feature GE washer, with their microband, the automatic dispenser. The only thing is, as good a design as it is, it's a wait and see, like anything else.
Yeah.
It's always the one thing you didn't think of that might become the problem. But we've sold a bunch of them, and there hasn't been a complaint per se. I mean, we haven't taken one back. We haven't, we've done about 5 videos on them, and we've probably had about, I want to say 300,000 to 500,000 people that have looked at them, and probably a few thousand people that have commented on it. And it's probably 95% positive. You get the isolated person, they got to return theirs because of whatever it was. But I really think they've thought it through, but only time will tell. I mean, I believe in the product, but we'll see.
Hey, Steve, can you comment on, I mean, how do you characterize the price difference between a heat pump dryer and a condenser or more conventional electric dryer of a similar size? I mean, what sort of price difference?
It's funny. I should have anticipated
that.
this.
I know it's hard because everyone's different.
I should have anticipated this question, which is why I probably can't answer it the way you want me to. But we sell most of the time we sell washer and dryer sets. Now, the really dominant set, which is Miele, is only heat pump. That's all they got. That's all they in 2020, I think, or maybe in 2019, they went straight 110 heat pump. That was it for them. That was their future. And they jumped on.
So they don't even offer an electric dryer.
They don't offer a condenser. They don't offer a vented piece, right? Bosch, we sell exclusively heat pump, right? It's actually cheaper to buy their heat pump than their 800 series condenser version, right? And then we get the wash tower, which is a bit more expensive than their regular one. It's about $300 to $400 more. But really, you're not getting. I think that if you were to ask Ken Rudolph maybe what he would be working on next would be just a full size electric heat pump dryer, because there really aren't ones that are that are really readily available on the marketplace, at least some brands brands we don't sell. I know LG's dabbled in theirs a little bit, Whirlpool's dabbled in theirs, but you're less than 0.5% of the market. And we try to sell better stuff. We don't even have it on display. So to give you a roundabout answer, Miele Bosch, it's about the same. The LG set is about $300 more. But if you buy the G all-in-one combo versus a regular G washer and dryer, it's $400 to $600 more, depending on whether it's promoted or not.
Okay, that's helpful. Yeah, to get an idea where to look. That's great.
So in other words, I mean, it sounds like basically what you're saying is that, the upcharge, there's an upcharge, but you're going to recoup those costs over a couple of years of using the device, most likely.
If you're replacing an old dryer and you're a family of 5, I got to believe the ROI is less than 2 years.
Interesting.
Because I think people underestimate how much energy this stuff uses.
Yeah.
And they certainly underestimate what they're paying per kilowatt hour, because I was shocked.
Yeah.
28.1 cents. Jesus.
Well, good. Joe, maybe we should
I think we covered most everything. Yeah, thanks, Steve. That was really great. We will send out the slides and some of the resources that we highlighted today, as always, along with the video recording either today or tomorrow to everyone.
Yeah, if there's any questions that come up that I haven't answered properly, certainly send them to me and I'll send them back to you.
There were a couple in the chat about some very specific models that we will follow up with email on, but yeah, Steve, thank you so much. That was
You're
fantastic.
very welcome, guys.
And to all our audience, thank you for tuning in today. And we hope we answered most of your questions. If you have other ones, don't hesitate to reach out to us. We'll try to make sure we get your questions answered. And good luck with all your electrification projects, and hope to see you at our next webinar on portable heat pumps.
Thanks, everybody.
Thank you, everybody.